So this video lesson is all about solving what we call two-step equations. Now the ones that we've been working with so far have been what we call one-step equations, where there is only one operation involved with our equation. Perhaps we have an x plus 7. In that case, our one operation is addition, and we can work backwards through that and subtract away that 7 to leave ourselves just with x. Perhaps it's an equation such as x divided by -2 is equal to 1. In this case, x is being divided, so we use multiplication to arrive back at the x. We sort of undo that division by multiplying by -2, and then we get an x all on its own. And the next level of equation solving that we want to go to as part of this lesson is an equation such as 3x plus 1 equals 16. And where this is different from the equations that we've seen before, such as 3x equals 15 perhaps, or x plus 1 equals 7, is that this one has two different operations that we're talking about. We have a multiplication in a 3x, and we have an addition with the plus 1. So when we go through and solve this equation, to leave x alone, we're going to have to multiply, or rather undo the multiplication by dividing, and we're going to have to subtract at some point in order to leave x alone and isolated on its side so we can tell what its value is. And so we really can do one of two things because we have these two operations. The order of operations would tell us to divide first, but when we divide something like 3x plus 1, we would want to divide it by 3. And so we're going to take this, and if we're going to divide first, we're going to divide by 3. And I'm going to give you just a second to work through that on your own and see what you come up with in terms of what x is equal to. Then we're going to go back, and we're going to do the subtraction first method. Then we're going to come back and see how that affects what it is that we're going to do and how it is that we're going to think when we want to multiply or divide first. So go ahead and work through this. See what you can do for it. We're going to go to the subtraction method in just a minute and then come back to the division. So let's say we want to subtract first. If we do want to subtract first, then we're going to want to subtract the 1 away first. Now, 1 minus 1 is just going to be 0. That's going to leave us with nothing. We're going to be left with a 3x on this side, not just an x. 16 minus 1 is 15. So we have a nice, easy division now. 3x divided by 3 is equal to x, and x is equal to 5. And so we find that in this equation, 3x plus 1, the value of x equals 5 makes the equation true. X equals 5 is our solution, and we can double check that by plugging the 5 back into the equation. 3 times 5 is 15. 15 plus 1 is 16, so we've got that first. And now what that means is when we divide first, we should get the same answer. We can't solve the same equation two different ways and get two different solutions. So if we just divided just the 3x by 3, what we would find is that x plus 1 is equal to 16 thirds. And 16 thirds is 5 1/3. Subtract 1, and we get 4 1/3, which is not the same as our value for x equals 5. And that's because when we multiply or divide something on either side of an equation, we have to multiply or divide by the entire side of the equation. It's not just the 3x divided by 3. It's the entire half, 3x plus 1 divided by 3. Now when we subtract first, we can just take 1 away from the 1 because addition and subtraction does officially affect the entire side. But the only term that it fits is this 1, which is a like term with addition and subtraction, and that cancels. But with division or with multiplication, we have to divide by the entire thing first. So we end up with x plus 1/3 is equal to 16 thirds. And when we subtract that 1/3 away, what do we end up with? Well, x equals 15 thirds, and so therefore x is equal to 5. And that leaves us with the two major things that we want to talk about when it comes to solving equations that have multiple steps. The first is that we really can do them in whatever order that we want. You have a choice of what operation to undo first, if that's how you choose to think about it. But we have to remember that if we choose to multiply or divide first, we're multiplying not just a single term, we are multiplying the entire side, or we are dividing the entire side. And so from that comes the recommendation that I have, which is when in doubt, add or subtract before you multiply or divide. And that will get you through with potentially easier numbers for every two-step equation that we're going to do in this class, and also is good to use in any class going forward. So let's look at two examples of this. We'll go through the process. We're going to use the addition or subtraction first, and then multiplying or dividing, and then there will be 3 pages each of 2 practice problems for you to pause the video and work on. So 6 problems altogether. So here we go for the 2 examples before our 6 problems. We have x divided by 7 minus 2 equals -1. As I said, we're going to be using the addition and subtraction first because we do recommend it because it will give you potentially easier equations. Certainly won't result in any sorts of fractions or anything like that that you wouldn't want to work with anyway. So here we have x divided by 7. -1 plus 2 is equal to 1. Now x is divided by 7. To undo that or to provide the inverse operation, we're going to multiply by 7. I'm going to write it right beside that because it reminds me of fraction operations, which we're going to get to in a bit. X divided by 7 times 7 is x, and 1 times 7 is 7. So x is equal to 7. We can double check that by plugging it back into the equation. 7 divided by 7 is 1. 1 minus 2 is -1, so we have our solution. This next one, 5 plus 2x is equal to -7. So here we're going to add or subtract first. We're not going to take away the 2x because we want to leave the x alone. That, or at least on its own side right now. It's multiplied by 2, and we'll get to that in a second. But what we really want to take away here is the 5, the constant that has no x attached to it. Here, 5 minus 5 is 0, so we just have 2x. -7 minus 5, the same as -7 plus -5 is -12. Divide both sides of this equation by 2 to get x is equal to -6. And so there we have our solution for the equation. We can double check by plugging it back into the original equation, but we'll find that we will get -7 is equal to -7 when we simplify it down. So the solution is x equals 6. So now the first of 3 pages of 2 problems for you to work on. Go ahead and pause the video and solve these 2 equations. Don't be alarmed by the equation on the right. It is just an extension of what we've done before. Think about how we can take the x plus 2 out of the parentheses. We have to take it out before we can do anything with it. We can't operate within the parentheses. We have to operate on an entire side. So see what you can do with that and come back when you're ready to hear the solutions and move on. So for the first one on the left, we have -4x plus 3 equals 11. We're going to subtract 3 from both sides and get -4x is equal to 8. Then we're going to divide both sides by -4. Remember, we have to take the negative away with it, otherwise we have the opposite of x. And 8 divided by -4 is -2. So our solution is x equals -2. And now for the one on the right where we had the 3 multiplied by the entire parentheses of x plus 2, this should look familiar as a distributive property. And as I said, we can't operate within a parentheses on a side of an equation, so we're going to have to distribute first. So here we have 3x plus 6 is equal to 12, and now we can go through and operate. Take the 6 away first. And then we have just 3x is equal to 6. And when we divide by 3, we end up with x is equal to 2. And we can double check that by plugging it into the equation. 2 plus 2 is 4, and 3 times 4 is 12. So that's our solution. Next 2 problems, we have -7x minus 1 is equal to 6, and x divided by -2 plus 3 is equal to 1. Go ahead and pause the video, work through these problems, and come back when you're ready to go through the answers, and then move on to the last 2 problems that we have. So for the one on the left, again, we're going to add or subtract first. Add 1 to each side to get -7x, or rather properly the opposite of 7x, is equal to 7. Divide both sides by -7 and get x is equal to -1. We can verify that by plugging it back into the equation. -7 times -1 is +7. 7 minus 1 is 6. And now for the one on the right, we're going to add 3 first, again using the addition or subtraction first. -3 plus 3 is 0, so we have x divided by -2, and 1 plus 3 is equal to 4. Now, x is being divided by 2, so we're going to multiply both sides by -2. I'm going to write it again on the side to remind myself that it's not the -2 that's being multiplied by -2. It is x divided by -2 that is being multiplied by -2. And this also, as I said, resembles fraction operations. So we want to write it this way rather than with the x underneath it, because that can just get confusing. So let's erase that here. X divided by negative 2 times negative 2 is just x. 4 times negative 2 is negative 8. So we have x is equal to negative 8. You can plug that back into the equation and see that we really do get 1 when we take x divided by negative 2 minus 3 is equal to 1. Now the last two problems that we have, again, don't be alarmed by what you see with the left-hand equation. Go through something that we've done before, and it will take you to an answer fairly quickly. And also then on the right-hand side, for x divided by 5 minus 9 is equal to negative 9. Go ahead, solve both equations, come back when you are ready to go through the solutions. So on the left, we have with 2x plus 3x minus 4x equals 9, there's a lot of multiplying and dividing that we could potentially do. But if you worked through it that way, you'll find that because when we divide, we have to divide everything by that, we're just going to get a whole lot of fractions, and it's just going to keep going around and around and around. So what we're actually going to do is we're going to combine these like terms, because by combining these like terms we can end up with a single term that has x, and when we divide or multiply or whatever it is that we need to do, then we can find an answer fairly quickly. So let's combine like terms. 2x plus 3x is equal to 5x. Then 5x minus 4x is just equal to x, or 1x. Everything here has been equal to 9, so that 1x is in fact equal to 9. And we can verify that by plugging it into the equation, finding that 2 times 9 is 18. 3 times 9 is 27, and 18 plus 27 is going to give us 45. And then 4 times 9 is 36, and 45 times 36 is equal to 9, or 45 minus 36, rather, is equal to 9. So our solution really is x equals 9. And now for our final problem, we're going to add 9 to both sides. Get x over 5. It's equal to negative 9 plus 9, which is actually the same. That's just 0. Now we could go through the process of multiplying both sides by 5. Again, multiplying up on the row of the equation rather than using the multiplication sign below, because again, it is x divided by 5, not just the 5 that is being multiplied by 5. 0 times 5 is 0, and x is then equal to 0. Or we could just look at this and say, well, the only number that can be divided by 5 to get a 0 is going to have to be 0. We can multiply 5 by 0. We can get 0 with a division. It just has to be 0 divided by something and not something divided by 0. So x equals 0 is the solution. So one more time to review those important things about solving two-step equations or multi-step equations is that we do have the choice of what operation to use first. We can go through it as long as we do it properly and get the same solution, but we have to remember two things, and that's first that if you multiply or divide both sides of an equation by something, it's an entire side, not just a single term, and that gives us to our second thing, when in doubt, or when all else fails, or just generally if you want to avoid those kinds of fractions unless absolutely necessary, add or subtract before you multiply or divide.